Okay, so please don't ask me when the next test is, I don't know. I do know we have lecture 6, 7, and 8, and then we have another test. So it might actually be this quarter, before the quarter ends. Mid-quarter grades ended today. So those of you who don't have the test, as soon as I have to, when I post them, you may have a missing score there. I'll try to leave it blank, but sometimes we have to fill it in, so just don't worry about it. Mid-quarter is just a snapshot.
It don't matter.
It doesn't matter. And quarter grades don't even matter either, because we just keep accumulating the grades until semester. The grade that really matters is in December. That's the one that goes on your transcript. And for UMKC, that doesn't even matter because it's the entire year. So only for high school does that matter. So the lecture 6, we have lecture 6, 7, 8, and then we'll take a test. So here we go. Lecture 6 has 2 parts to it. The first one is distance, and the second one is midpoint. So yes, you are going to have a couple formulas we are going to be using for distance and midpoint. Okay, so let's review real quickly. This should be review. We have the XY graph, Cartesian plane, whatever you call it. Tell me everything you know about the Cartesian plane.
There's dots.
Okay, yes.
Like the positives go up, the negatives go down, the
Positives
go
go
right,
up.
negatives go left.
Goes down, then the positives go to the right, and the negatives go to the left. Did I catch everything you said?
Yeah.
Beautiful. What else?
X is the left or right.
X-axis. Several years ago, I did have a student come to calculus class, and she was like, now the x-axis, that's the one that goes up and down, right? I was like, oh, no, we're in calculus, we should know which one. So what's the other one called?
Y.
Y-axis. Would you like a little bonus today? A little bonus information?
Yeah.
There's a third axis.
What?
It comes out in 3 dimensions, out this way. And what do you suppose we call that one? Z-axis. So if we decide to go into 3 dimensions, we'd have the x, y, and the z. That goes right doing that in college algebra.
Interesting. I was thinking about 3D graphs when I was trying to fall asleep last night, so it's funny that we talked about it.
There you go. You had a premonition. What else do you know?
There's numbers.
Say it again.
There's numbers.
Explain.
They can be 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5. There can be decimals. Yeah.
You're correct.
Wow.
Absolutely.
It's like the combination of 2 number lines.
Yeah, it actually is. If you remember back when you were in elementary, you started off with the number line, and that's actually the x-axis. And then we just turned it on its side and said, okay, here's another number line, and now we have a y-axis. Okay? In fact, let's take that a step further. Okay? When you were in elementary, you learned the number line, so these were the real numbers. What do you suppose the y-axis is?
Also real number?
Nope, it's the
No.
imaginary number.
Okay.
We can actually graph complex numbers. Okay, what else?
Why is the y-axis imaginary?
That's a great question.
So like if we gave you 2 plus 3i, imaginary number, right? This is your real number, so that's on your number line. So if it's not real, it's imaginary, so it would be on the y. This is your x value, this is your y value.
The more you know.
This is actually the same as 2, 3. If we were going to graph imaginary numbers.
I would never guess that.
Yeah. All right, what else do you know about this? Yes,
There's 4 quadrants.
there is 4 quadrants. Can you tell me which one's the first one?
Positive,
They're in a-
positive.
Positive, positive. So that's 2 ways to look at it. This, all the ordered pairs here are going to be positive, positive. And that's the very first quadrant. And we always use Roman numerals. Okay. And then which way do they go?
Like that, angle like
They do not go clockwise. They go counterclockwise. Very good. So this was going to be my second quadrant. And that's going to be an x value that's negative and a y value that's positive. And then we have our third quadrant, where both of them are negative. And then we have our fourth quadrant, why the first one is positive and the second one is negative. If you'd like to know why they're numbered backwards like that, come to pre-calc or take a trig class. And you'll learn why it's 1, 2, 3, 4 in that direction. Okay, what else?
that.
One more thing.
There's one more.
It's important.
Is it like the bell curves and exponentials and stuff like that?
Oh, the origin.
Oh, origin.
Origin, outstanding. Origin. Right there, and its order pair is 0, 0. That's where everything begins, right? And of course, we didn't talk about it, but everything can be marked in an ordered pair. So something like, let's see here, this point right here would be -2, +3. And you can tell just by looking at an order pair what quadrant it's in. Yes.
Can I ask a silly question?
No.
Okay.
You can ask a question. Just.
Okay, can I ask a question? So when we say origin, like my origins are, which one came first? Like the origin of a graph with 0, 0, or talking about where something started, like the origin of a human being?
I have to say no one's ever asked me that question before. I would probably say about the origin of people as opposed to the math has been around for a long time. This is just where everything starts, so maybe it took that definition.
Yeah. I'll ask Google later.
Yeah, ask that question. Google it. Google will know.
Google it.
All right, very good. So when we talk about distance and midpoints, we're talking about distance and midpoints on a graph. Okay? So let's look at, first of all, the distance between 2 points. I don't think we've talked about this yet. Maybe we have. Forgive me if we have. But the distance between points and its notation. We can notate in several ways. One way is to do the distance between point 1 and point 2. Distance between point 1 and point 2. So let's take my graph. And I don't have a little thing I could put up here and put a graph on here. We're just going to have to do it by hand. So let's just make a point here. We'll call this point 1. And come over here and we'll make this one point 2. How am I going to find the distance between those two? Well, remember back in geometry, you had this formula. If I were to draw a horizontal line through point 1, and I were to draw a vertical line through point 2, or vice versa, I could do a vertical through point 1 and a horizontal through point 2, either way. I'm going to create what? Nice little right triangle, correct? Okay, in fact, this is called a rectangular graph because if I do connect the horizontal and vertical lines through each of them, I've created a rectangle. Okay, that's why it's called a rectangular graph. Sorry, it's not perfect, but I'm trying to sketch this in. So how do I find then the distance between these 2 points? Say it again. That would be slope. Another very important concept.
Are we calculating like the interior of a right triangle?
I'm looking for the diagonal of a right triangle, the distance between those two. See if I can make a better straight line. So I've created a right triangle. So how do I find that side of a right triangle? What do we call that side of a right triangle? We have a right triangle with the right angle here. So opposite that, what do we call that side?
Hypotenuse.
The hypotenuse. And how do I find the length of the hypotenuse of a right triangle? Most famous one in all of math. What's that? So what's the name of that formula? It's super famous. And it's a great name for a kid. What's the name of that?
A great name for a kid.
ABC.
Oh.
A squared plus B squared equals C squared.
Yes.
All-
Pythagoras, a great name for a kid.
It's terrible. That's so sad.
Pythagoras?
That's like
I like
Kanye West.
I wanted to name my first son Pythagoras. I saw Celeste Phillips. I think it's a great name.
Yeah, that's
Oh,
cool.
Your wife
Nickname
probably
Pip.
had a heart attack.
Alright.
What'd you say?
Your wife probably had a heart attack.
Yeah, she just laughed at me and thought I was joking. I'm like, Okay, so we're going to use the Pythagoras' theorem. Okay, a squared plus b squared equals c squared to actually find the distance here. So if I were to take these 2 points, and we'll call point 1 is going to be x1, y1, doesn't matter what the points are. And point 2 is going to be x2, y2. If I'm going to find the distance between these two, if you remember, the distance is simply the absolute value of x2 minus x1. Does it really matter which way I subtract them? Because I'm doing absolute value. I can do x1 minus x2. Doesn't really matter which order I put them in. Okay? It's just traditionally we always do the second one first. So then, and we would call that actually the change in x. We call that delta x, how x has changed. How far has it gone from point 1 to point 2? What do you suppose the up and down is going to be, the rise part? The absolute value of what's changed here. Well, if x has changed here, what's changed here? Y. So it's going to be y2, the absolute value of y2 minus y1. And we call that the change in y. So these are the 2 legs of the triangle. And that gives me the a squared and the b squared. So I'm going to have the absolute value of x2 minus x1 squared plus the absolute value of y2 minus y1 squared is going to be equal to what? Between P1 and P2. The distance between P1 and P2. So then let me change sides here. The distance, in fact, you know what? We know it's P1 and P2. Let's just use the letter D. Is that okay? Can I do that? Rather than doing the distance of P1 and P2, I'm just going to use D. Now, I have a question for you. Whenever I square a number, what type of number will it be? Will it become? If I take 1 squared, what do I get? If I take 2 squared, I get 4. What if I take negative 1 squared? 1. What if I get negative 2 squared?
4. So it's going to be positive.
It will always be positive, right? Either going to be 0 or positive. So do I really need the absolute value? Because it's all, absolute value just means it's always positive, right? And squared means it's always going to be positive, right?
Right.
So let's just get rid of the absolute value. Let's just do x2 minus x1 squared. And once again here, the absolute value squared is kind of redundant. Let's get rid of it. y2 minus y1 into y squared. Oh, and that's going to equal the distance, because c squared is c squared. So we have our a squared plus b squared equal to Pythagoras' theorem. Okay, someone tell me, how do I get rid of the squared? Square root both sides, right? Now, can distance, Ava, this question is for you. Can distance ever be negative?
Yeah. No. Yes.
Okay, you gotta pick one. You're
Yes.
killing me here. Distance can be negative.
Yes.
Give me an example.
Okay. So, like, when you're going backwards, that's negative.
Okay, so if my car
Unless
goes in
it's not.
reverse, does the odometer go backwards?
No.
If you think it does, watch Ferris Bueller's Day Off. So the odometer doesn't go backwards. You're still distance, right? If I'm going backwards and I go back 3 steps, how many steps have I taken?
Take 3
Still
steps.
take
Okay,
3.
I see.
So can distance ever be negative?
No.
No. So when I take the square root, all I have to do is focus on the positive one. Okay? So distance is going to be equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, and there is your distance formula.
I forgot about that.
You've seen that before, right? And that's all the place it came from. Pythagoras' theorem, and just realizing squared means the same as always positive, and distance always has to be positive. And once again, it doesn't really matter which order I put the x's in and which order I put the y's in. Okay. All right, so let's go and use the distance formula. You don't need to write it again unless you just want to. I'm gonna write it up here. We're gonna try and write it up here. So y squared. Okay, so let's pick 2 points. Give me a point. Point 1, give me a point. 7, 2. I have to have a word for it. So 7, 2. All right, give me another point. Make some negatives in there.
Negative 4.
Negative 5, 4. Okay, negative 5, 4. How far apart are these 2 points? If I was to travel from one to the other, do I need to graph it?
14.
Do I need to graph it? No, I don't need to graph it. Let's just go ahead and find it. So distance is going to be equal to the square root of, I know it's going to be minus. Does it really matter which order I put the x's in? No, as long as I do 7 minus the negative 5 or negative 5 minus 7. Either way, I'm going to get the same answer. Okay. I'm always going to go the same though. So 7 minus the negative 5 squared. Plus, what about the y's? Do I do 2 minus 4 or 4 minus 2?
Either one. 4 minus 6.
Doesn't matter. 4 minus 2. Although you should put a minus sign in there, not a comma. 4 minus 2. All right, so we simply have plug and chug, making sure these two go together and these two go together. The biggest mistake I've found is students will do 7 minus 2 and negative 5 minus 4. They'll do x, y, and x, y. Can't do that. Do the x's together and the y's together. And then we call this plug and chug because you plug in the numbers and then you just solve it. The square root of, what's 7 minus the negative 5?
12.
12 squared is 144. Plus, what's 4 minus 2 squared?
4.
I want to let somebody else answer. You're all right. I'm glad you're with us. That for the distance is the square root of 148. Now, to be honest, when it comes to distance, I don't really like leaving answers as the square root value. I'd rather have it as a number. Okay? So, you have a calculator. Can you give us the square root of 148? Should be like 12.1 or 12.0.
So, 21,912. Oh,
Square root.
root.
12.2. It was about 12.2. Okay, questions on using the distance formula with that? Yes.
So, last unit, you talked about not leaving decimals, you preferred fractions. So, how would we go about making this into a fraction?
So it's irrational,
Yeah.
so there will not be a fraction for this one.
Okay, so just leave it as the decimal.
You
Like
can leave it,
the ultimate decimal.
honestly, as long as you leave it reduced and radical, you can do that.
Okay.
I just personally, if I'm looking at distance on a number line type thing, I like to have a number.
Okay.
So I like to have 12. But either way, it's going to be right.
Got it.
And no, you can't always take these as fractions. Good question. Others? All right. Try this one on your own. You try. And once again, you don't have calculators. You don't have calculators. That's fine. You can leave it as a radical. I'm going to give you 2, 6. So what quadrant is 2, 6 in? First. And 1, negative 6. So that would be in what quadrant?
4, very good.
Find the distance between those two. Does anyone need more time?
No.
Good? We good? Speak now for hold your peace. In a minute? Yeah. Our application. Okay, so what's going to go in the first blank? We have the distance equals, we have the square root, and then inside those first two parentheses, what number is going to go there? Doesn't matter what order? 2 minus 1. Okay. It's going to go in the second one. Doesn't matter which one? So I'll do, let's just play it around, -6 to 6. Okay. So we should get the distance is going to be equal to, let's see, 1 plus 144, and you should get the square root of 145. Which I wrote down the wrong number because you're supposed to get the square root of 125. I wrote down the wrong ordered pair. It's supposed to be -3, -4.
It's kind of funny that we ended up with almost the exact same order. I mean, the exact same number.
Yeah.
This one that we did in the last one.
Yeah, that's what's supposed to happen. This was supposed to be -3, -4. So I screwed up. My bad.
Well, I got 12.04.
Yeah, I got
I got
12.
Because he rounded up even though it's a 4, not a 5.
12.04.
You can round up when it's
The fact that you did it in your
That's
head
what I always,
beyond
that's what I
that was
always guessed too,
impressive.
12.1.
Yeah, it's just a little over
140, or what?
144 is 12. So it's just a little bit
148 was 12.2, so you
See, but the fact that you got that in your head is far beyond me, so you're right.
My bad. 12.04. Okay, are we good?
Sorry that I did it wrong.
Are we good?
Yeah.
Questions? All right, you ready for the test question?
Sure.
Now pay attention to this one. Here's an actual test question. It's an application. Application. How much time do we have? Oh, good. We have plenty of time to get through this. Application. Given. Point 1. I better write these down correctly because I don't have to fix this. Point 1 is -25. Point 2 is going to be 130. And point 3 is going to be -1, oh my gosh, -10. Okay? Using the distance formula, the question's gonna say using the distance formula, because there's other ways to do this. So I want you to use the distance formula, to determine if these 3 points, when connected,
Okay.
who said okay? Is there a problem?
No.
Are you writing? This is a test question. You might want to write this down.
The whole question?
Yeah.
Alright.
Using the distance to determine if these 3 points, when connected, create a right triangle. Create a right triangle. Use the distance to determine if these 3 points, when connected, create a right triangle. Like I said, there's multiple ways to do this using other formulas, other techniques, but it says specifically use the distance formula. Okay? So let's find the distance between all 3 of them. Okay? So let me see, let's split you up into groups. The distance between point 1 and point 2. Okay? Let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. U4 right here. Work on it right now. Find the distance between point 1 and point 2. Okay. The distance between point 2 and point 3. U3. U3. Okay? And then the distance between point 1 and point 3. U5. Okay? Find the distance between point 1 and point 3. Find those 3 distances. And if you will, leave them all in radical form. Don't even reduce them, just leave them in radical form.
Yeah. That's what I got to
Done already?
Yeah. I think. Could be wrong.
What are you doing, 2 and 3?
Yeah. That's what you got.
That is what you should do. Make sure everyone agrees. Is that your answer? Do they agree? I'm gonna ask Cassidy too.
I got it wrong.
What? I can square it with
Okay.
Which one were you doing?
How did you get one?
Wait, never mind.
I think you did the X's and the Y's.
Yeah?
How do you?
Negative or just here this? I don't know where
Oh, you did 1 and 3. Yeah, so you just missed the. That would be 0.
Minus 1.
Okay.
Positive 2 minus 1. Wait, is that equals 2? Is it 1?
Are you all in agreement?
Yeah.
Did you ask Cassidy?
Yeah.
You sure?
Yes.
They're just making that up, right?
Yes.
Alright. So you got the square root of 13,
Yes. Oh, it ends up being positive.
and you got square root of 13?
I was doing the.
Just waiting on you 5 to discuss this and make sure you get the right. You better ask, make sure they're all there.
Now hold on. Now hold on.
The rest of us can sing Jeopardy.
-2 minus -1.
-2, yeah, and then minus -1.
But then
positive, which equals -1.
We have to square it.
Right, and then you square root it, that's 1.
Yeah. Right.
Square it, that's what.
That's square, yeah.
And then
And it's 1, and then
-1 plus 1.
plus 1 5. That's what you have to do at the end, it's 26.
Oh.
Yeah.
Square root of 26.
Yeah, because you square it and then it's 1, because the negative.
Because then it's,
Oh, because after you square it, it's not.
everything's always positive.
It's going, yeah.
You're right.
So you said what?
Square root of
Square root
26.
is 26.
Those will always be positive.
Yeah.
Okay, so we have the square root of 26. So, do these 3 side lengths create a right triangle? Well, let's see. Which one of these would be the hypotenuse? If it was a right triangle, which one would be hypotenuse? Why the square root of 26?
Because the longest.
It's the longest, right? So if I did a squared plus b squared equals c squared, c would have to be the square root of 26.
Right.
Therefore, the other 2 would have to be the legs. Whoops, squared. So what is the square root of 13 squared?
13.
13. So the square root of 13 squared again would be 13. What's the 20 square root of 26 squared?
26. And it's almost like 13 percent.
Is that a true statement?
Yes.
True. Therefore, it's a right triangle. Oh, that's not a triangle. Therefore, it's a right triangle. Okay. So we use the distance formula, found the 3 side lengths, and just plug it into Pythagorean theorem and say, hey, is this true? If this was a false statement, then no, it's not a right triangle. In fact, we could say if this was a bigger number, it would be an obtuse triangle. If this was a smaller number, it's an acute triangle. Should have learned that. Okay, questions on the application? I don't think you're gonna see that in Desmos. So Ava, that's why I really wanted you to write that out and work through it, because you're gonna see that, but you're not gonna get a lot of practice with it. Okay, it's just an application of using all those things. I would suggest you put TQ by it, standing for test question, and before we take our quiz, you might wanna make up a couple problems and try them and see if that works. See if you can figure it out. All right? Questions on that process? Okay, so when we come in on tomorrow class, we will pick up with midpoint. Okay. Now there is Delta Math. I don't know that I put it out there yet, so you may have the night off. And then tomorrow we'll make the assignment after we cover midpoint. Okay. Any questions? Let me know.
What about Lee?
Question. So I
Wait about 5
didn't
minutes.
realize that I didn't get to the last 3 questions of the Delta Math before I got sick. Can I do those last 3 questions?